everyone. Today we are going to study about hydropower plant and efficiencies. Hydropower. In the word itself there is a definition. Power is generated from hydro. Hydro means water. The water stored in the upstream side of the dam having potential energy. The flowing water is having kinetic energy. Both potential energy and kinetic energy are used to generate the electricity. Hydropower is the renewable source of energy. It is available for a long time. Even there is seasonal variation. Then the water will fill by rain or due to melting of ice, etc. The hydropower units. There are different types of hydropower units. The first one is water wheels. Here the wheel is fixed below the surface of water or on the surface of water. Here the flow of water which causes the rotation of the wheel which is connected to the generator. This wheel converts the hydraulic energy into mechanical energy. The generator which is fitted to this which converts the mechanical energy into electrical energy. In case of hydropower plant, dam is constructed across the river. The water stored in the upstream side is taken through the penstock to the turbine. The turbine converts hydraulic energy into mechanical energy. The turbine coupled to the generator which generate the electricity. Next one is wave energy from oceans. The waves present in the oceans having kinetic energy. This is used to generate the electricity. Next one is tidal energy. Here tidal energy power plants here the gravitational effect of sun and moon causes the variation in the height of the waves in the ocean. This effect the tides are generated. These tides are used to generate the electricity. Next one is damless hydropower plants. Here dam is not constructed. The flowing water is used to generate the electricity. Maybe waterfall, the water flowing with the high velocity, etc. are used to generate the electricity. The next one is classification of hydropower plants. There are different types. The classification is based on quantity of water available. There are two types. First one is run-of river hydro plants. Here dam is not constructed. The flowing water is used to generate the electricity. It means reservoir, dam is constructed. The reservoir formed from this is used to generate the electricity. The next one is based on head of water available. There are three types. Low head hydroelectric power plants. Here Kaplan turbine is used. Medium head hydroelectric power plants. Here Francis turbines are used. High head hydroelectric power plants. Here Pelton wheel turbines are used. Head available is very high. Next case is based on nature of load. Load means the demand, the requirement. So base load hydroelectric power plants and peak load hydroelectric power plants. Here in base load hydroelectric power plants, the load means the demand is average. So throughout the day there is a demand. To meet this demand, the hydraulic turbines operate for 24 hours almost throughout the day. But in peak load hydroelectric power plants, here the demand is only for some duration. Example, the colleges, factories, schools, offices, etc. starts at 9 o'clock and maybe end at 5 o'clock. The demand for the electricity is more between 9 to 5. After that, the demand decreases. So to meet this peak demand, some of the hydroelectric power plants operates. So that hydropower plants are known as peak load hydropower plants. This is a layout of hydropower plants. A dam is constructed across the river. The water stored in the upstream side is called as reservoir. The purpose of dam is to store the water in the upstream side. Dam, there are different types depending upon the material used, the purpose, etc. The water stored in the upstream side of the dam is taken to the turbine through a large diameter pipe is known as penstock. The one end of the penstock the decreasing diameter pipe is fitted. It is known as nozzle. The water coming out from the nozzle is known as jet. The jet is striking the series of vanes which is fitted on the runner. Runner is fitted on the shaft. This shaft is connected to the generator. When high velocity water strikes the vane, the runner rotates. After that, the water will go out as a waste. This water is collected in the channel and is taken to the river. The water surface, the difference between the water surface in the tile race, the water surface of the reservoir is taken as gross head. When the water flows from one end to other end, there will be some losses. The losses are classified into two types, major loss and minor loss. The major loss is mainly due to friction. Minor losses are due to pipe pitting. So pipe pitting here, minor losses are negligible. So here only friction loss is considered. Friction loss, that is gross head is Hg or Hs. This is gross head. The net head is the gross head minus loss. This is Hf. Hf or head loss, HL or HL or Hf is equal to 4f Lv square by 2gd. So d is the diameter of the penstock, v is the water which is flowing in the penstock, L is the length of the penstock. Here you can see the surge tank. Surge tank is the tank fitted to the penstock. When the turbine need to be stopped, the gate wall is closed. The purpose of wall is to control the flow of water in the pipe or penstock. When the gate wall is closed, the wall is closed, the water will flow in the opposite direction with the high velocity. It will impact on the sides of the penstock, even on the gate. To reduce this effect, this is called as water hammer. To reduce this effect, the surge tanks are constructed. So here, when the gate wall is closed, the water will move in the reverse direction. Then water will rise in the surge tank. The purpose of surge tank is to control the effect of water hammer. So these are the different parts of hydroelectric power plant. Turbine house. Here turbine house means the turbine, it consisting of a series of vanes. The water from the upstream side will flow, it will be carried through the penstock. Penstock is nothing but larger diameter pipe to the turbine. The turbine rotates, it is coupled to the generator. The turbine converts hydraulic energy into mechanical energy. The generator which converts mechanical energy into electrical energy. So you have to recall this. So last chapter we have studied about the series of vanes. So force exerted by series of vanes, it is by using momentum principle. So force F is equal to mass of fluid in the jet into initial velocity minus final velocity. Initial velocity, that is VW1. VW1 is wheel velocity. VW2 is the wheel velocity at the outlet. So plus or minus sign depending upon beta is plus, less than 90 degree or more than 90 degree. Force is equal exerted by the jet on the series of vanes is equal to rho AV1 into VW1 plus or minus VW2. A into V is equal to Q. Work done is equal to Fx into U. U is velocity of the vane. Force over work done over. Next one is power developed. Power developed is equal to work done divided by 1000 in kilowatts. Next, efficiencies. Hydraulic efficiency is the ratio of power developed by the runner to the power supplied at the inlet of the turbine. Look at this. This is a pattern wheel. So, to rotate this runner, some water need to be strike here, right? So, the water, what is the forces applied by the jet? That is water power. That is water power is equal to WH by 1000 is equal to rho GQ H divided by 1000 is in kilowatts. Now, when the jet strikes, the runner rotates. The power developed or power delivered to the runner at this point, right? That is known as runner power. Runner power is rho Q VW1 plus or minus VW2 into U. Actually, Q is equal to A into V1 divided by 1000 actually here. For pattern wheel, at the inlet and the outlet, the vane velocity is same. But in case of reaction turbines, the vane velocity will be different at the inlet and outlet. So, that case, here rho A V1 into VW1 into U1 plus or minus VW2 into U2 whole by 1000. So, this is the final formula for hydraulic efficiency. Remember, hydraulic efficiency is equal to runner power by water power. Runner power by water power. Next one is mechanical efficiency. Mechanical efficiency, here the ratio of shaft power to power developed by the runner. See, shaft is rotated only when the runner rotates. So, the power, first this runner rotates. So, here runner transfers the power to the shaft. So, power available at the shaft of the turbine divided by runner power is equal to mechanical efficiency. Mechanical efficiency is equal to shaft power by runner power. The next one is volumetric efficiency. Volumetric efficiency here, even when the water from the jet comes, water from the nozzle, right, it strikes the buckets or the vanes of the turbine, okay, some quantity will go out without striking the buckets or the vanes. So, the volumetric efficiency is the actual water which is striking, actual volume of water which is striking divided by volume of water which is supplied at the inlet. See here, capital Q is the actual water which is supplied through the nozzle or at the inlet, but here minus delta Q. Delta Q is some quantity of water which won't strike the vane. It will go out as a vane, just go out without striking the vane. Last one is overall efficiency. Overall efficiency is, so when the water is supplied here, what is the power available at the shaft? That is the ratio between the shaft, right? Ratio of shaft to the water power at the inlet. So, overall efficiency is equal to shaft power by water power. Just look at here. So, RP, runner power multiplied here. So, take here shaft power, this runner power this side, water power to this side. So, shaft power divided by runner power is mechanical efficiency. runner power by water power equal to hydraulic efficiency. So overall efficiency is equal to mechanical efficiency into hydraulic efficiency. These are the references.